Hi, these are the solutions to sheet 4, more stuff on auxiliary ideals, in section 14 of my Formalising Mathematics course. So this is just some useful technical lemma which we'll need later. And what's the claim here? We've got an element C of our ring and a proof that it's in the auxiliary ideal. And so that means so C is in the span of the generators, right? This hr.gens thing. That's what assumption HCI gives us. And there's this key intermediate step here which I'll just copy down here. Boom. Does that compile? Yes, that's compiled. So this says that the generators are just a subset of what you get when you start with the generators, and then you lift them via the lifting map, and then you map back down with the coefficient map. I mean, these two sets are equal really, but we only need an inclusion. So C is in the span of the generators, so that means that C is also in the span of these objects. So in particular, C is in the span of the image of a ring homomorphism. So maybe I should show you that. How do we know that C is in the span of the generators? We have some lemma that says any ideal. This was back in sheet 2, I guess. There it is. The span of the generators of an ideal is the ideal. So we want to rewrite this this way. And HCI, and it doesn't know. No, it doesn't know what span gens are. This is Noetherian ring.spangens, so hr.spangens. Has that worked yet? That still needs some help. How annoying. hr.span. Isn't that annoying that it doesn't give me the pop-up? So check what was this called? Is Noetherian ring.spangens. That one there. So it wants the proof that the things in Noetherian are, then it wants an ideal. So why don't I just say guess the ideal? Why don't I say guess the ideal there? And why don't I just say guess everything? No? Oh, how frustrating. So what is this thing? This span gens thing? Says that the ideal span of the generators of J are J. So it's aux ideal. It's clearly aux ideal. Will this work? Yes, this magically worked. How funny. I was expecting the rewrite to need less hints than that. So now C is in the span of this set here, and assuming H, we've skipped the proof of H, right? But let's just see that H does it. Assuming H is true, these generators are a subset of some other things, and so the span, if you make the set bigger, then you make the span bigger. So we should be able to replace HCI with, I don't know, submodule.span mono or something, and then HCI. Is that? Yes. And now we've got C is in the span of the image of a linear map, and so now we can rewrite what was that thing called, submodule.span image at HCI there. And now we know that C is in the image of the span. Right, C is now in the image of the span of something. So that object, so now I can do R cases HCI with Y, HY there, and then I can use this Y. And now HY is in fact possibly exactly the same. We could try exact hy. Didn't work. What about try simper using hy? That might work. That did work. There we go. So modulo. You see, the reason I went for simper using hy. You see, I've got this fin set image, and then here I've just got the set image. But somehow fin set image and set image are known to be the same thing. The simplifier can do it. So we're nearly done, except we haven't proved h yet. So h, we've got to prove that something is a subset of something else. So let's intro r, and then hr, intros. What have we got here? R is in the ring, and it's in the generators of the auxiliary ideal. Then we've got to prove that R is in the image of the linear map, right? So we use lift, right? R is one of the generators, so we can lift R. So we can use lift INR, I guess it's called. And now what? Oh, I suppose I could refine. Instead of use and then split, we could do refine this thing here. And then we could do the split automatically. Split. Does that work? Yes. So this says the lift is in the image of the lifts of the generators. This is somehow obvious. How far does by simp get? Oh, but we need to tell it HR or something. No. Okay. And what about the last proof? The last proof is that the coefficient of the lift of R is R, and we know that R is in the generators, so that we did before. That I think was in sheet 3, right? There, it's lift spec HR. So this maybe is lift spec HR. I might have to give it more things. Oh no, it's h little r, sorry. Oh, curses. Oh, how annoying. So we're not quite ready yet. R is in the generators, and therefore R is in the span of the generators. What was the error again? I want R is in the generators of the aux ideal, therefore R is in the... So I need that the generators are a subset. I just need some kind of subset span or something. If I do that, now what are my two goals? Yeah, this looks good, doesn't it? So the first one should be, I mean, why is it in the image of the generators? Because it's a generator, so we could use R, I think. Use R, sorry. And then this one is sorry. Use R doesn't work. So what's the simplifier say? Oh, there we go. So now I can use R. And now I've got to prove that R is in the generators, which is HR, so I can actually refine RHR something. And now I've got to prove that, and that's REFL. So that does the first one, and now we've just got, what have I done? I've lost a comma there, and I've just got one left, and this should be obvious. I'm in the generators of an ideal, and I've got to prove it's in the ideal. So was that, did we do that in sheet 2? Yeah, gen subset. So let's apply gen subset. Never heard of it. Is Noetherian ring dot... we need Noetherian at this point. HR.gen subset. Let's try that. And now the only goal left is h little r. So we'll probably put h little r there. We can't. We have to... It's an ideal. There we go. So that looks good. That's compiling. I think I can get rid of this. And that's the proof of the first lemma. And now the second lemma, slightly easier. This says P is in the span of a whole bunch of lifts, a span of lifts of generators, and so Y is the degree at most n, and that's because so we can change P is in MRN, right? Yeah, to be degree at most n is this. And now I claim that, so you see this is this, it suffices to prove that the span of this mess here is a subset of this. So I could revert HP there, and that follows immediately from the statement that the span is a subset of something. So can I apply so I could change, this is span, this is submodule dot span R something is a subset of, is less than or equal to MRN, right? No, it's not. Annoying. I mean, it is, isn't it? Maybe we should just do. Maybe we should just do. This is a shame. This, I'm just sort of trying to. I'm trying to. I'm trying to avoid having to write this thing down here. It suffices that the submodule dot span of this thing here is less than MRN. That's what I'm trying to get it. The span of this gigantic set is at most MRN. I've still R. It's the R span. Bingo. So I claim it suffices to prove this thing here. And now I can apply this and hopefully change the goal into, yeah, P is in submodule R, and that's exactly HP it should be, yes. So HP. Right, so this is exact HP. There. And now what? I now want to prove that, you see that the span, now I want to rewrite submodule.span LE or something. Yes, because that says to prove that if the span of a set is a subset of a module, it suffices to prove that the set itself is a subset of the module. And so now this should be easy. What does it actually say? Intros F, was it called? What is F? F is a polynomial, so intros FHF. And then let's simp as HF, let's see what it says. Right, so now we can actually do cases. We need to prove that the lift, so the hint tells us this, what's this? Have colon equals this. Oops. Have colon equals this. This says, the lift. This says the lift of a nat degree is at most this. Okay. So we could apply lift nat degree. We could probably apply it. Lift nat degree LE. Does that work? No, it doesn't. Maybe we could refine it. No, have I got something wrong? Okay. So I wonder how far does definitional simping give us at HF? Oh dear. So what's just happened there? It's used some fancy theorems. Okay, so terrific. I think we just leave it as simp at AF. So now we can do cases. Our case is HF. with something. R, HR. Let's see what. Have I used an R already? No, I'm all right. R, HR. And then this F here, this could just be a ref, right? There. And now I've got to prove that the lift is in this. And now now I probably can apply lift nat degree LE. Because that says exactly that. Yeah, there we go. And that looks like the end of that proof. Great. And so that's the end of this sheet. Thanks very much for watching.